This is the first video using the base model, and I'm going to get started by changing the parameters here to better reflect our system, which is going to be Massachusetts. And I'm going to start by setting our initial population to 6.9 million because that's how many people are in Massachusetts. And I've just put a green fill there to help me remember which variables I'm changing. I just find it helpful to kind of keep track of changes I make. Oh, you know what? The very first thing we should do is we should make a copy of this. So go down, if you right click it and you make a copy or a move, you select copy and click on epidemic and create a copy. So let's work with that one. This way, if we make any changes and we screw it up, we can just easily go back to the original file here and start again. Because in Excel, I find at least, it's very easy to make mistakes, and it's nice to be able to quickly look back at a solidly working version of the model. All right, so let's continue making changes in this one. So this was 6.9 million, so 6 million people. Looks right to be Massachusetts. And if you notice, the scale has changed here on the y-axis, but the general shape looks the same. I'll go up here and clicking this will undo it. You see that the model is somewhat insensitive to what the population is. It's which is fine. The other thing we were going to change is ICU capacity, so I'm going to color that to take note of that. And I'm putting this at 1,000 beds because that's how many I estimated were in Massachusetts. If you notice there, the model seems really insensitive to that change. It barely moved at all on there. I didn't even detect any movement. If we put this to, let's say, 50,000, let's see if it, yeah, even 50,000 doesn't seem to make much difference there. So anyway, we'll put 1,000 because that's what I'm thinking for Massachusetts. Now I'm going to just left click this and drag it down to make some room to put some new parameters in. So these are your parameters in the model. These are values that you set at specific values, and they don't change as the model advances through time. Your variables, on the other hand, are over here. These are your variables, and they will vary as this is a variable as well, time. So these things change in the model, and our units here are time. So as the model advances through time, you see the values. Each new row has a different value for these variables. So variables vary over time. Parameters, no matter what time in the model, what time step it is, the base transmission rate is always 1.1. The mean sick infected period is always 18. So these variables are constantly referencing these cells over here that have a consistent value. So, okay, so we are wanting to add a parameter in our model to represent social distancing, the aggressiveness of social distancing. So we'll call it social distancing aggressivity. And this is going to range 0 to 1. Let's start it at a 0 just to begin. And I'm going to make a note here that this ranges 0 to 1. 0 equals no intervention. 1 equals complete social isolation. Okay, so this is going to impact our transmission rate. So we have a base transmission rate of 1.1, but as this goes from no intervention, a 0, to 1, which is complete social isolation, we're expecting it's going to have a linear relationship on transmission rate. So we're expecting that it's going to linearly decrease transmission rate. And in order to put that in the model, let's create a parameter name. So call it alternate transmission rate. Transmission rate. Okay, so you put in equals. This is telling Excel you're going to put in a function. And so we want to do the base transmission rate times our social distancing aggressivity. So if I put that in, it will be a 0 because we're multiplying by 0. So that's not what we want because we're expecting, and let's see if I put this as a 1, that's going to become 1.1. So that's a linear relationship like we're looking for, but that's saying as the social aggressivity increases to 1, the alternate transmission rate also stays the same. What we want it to do is to be decreasing. So what we do there is we do this minus that. So that's going to flip it. So as as this one goes up, the alternate rate is going to go down. So now that we have a 1 here, so this is complete social isolation, your alternate transmission rate has become 0. If this is a 0, this should switch to a, this should become 1.1. And so it does. So our function works as it should. If we put this to, let's see, 0.5, that's half of the base transmission rate. So that's exactly as we expect. We put this to 0.95, we're getting closer to 0, which we would expect, because as we get to 1, we get 0. All right, so that is that's working as it should. That's how the relationship exists between our social aggressivity and our base transmission rate. So now we have this alternate transmission rate, which is our new new parameter. So the other thing we have to do is decide a date of intervention. So at what date in our model do we want this social distancing to be implemented? So as you can see, the time is here. So I'm going to specify, let's say, day 18. No, I'll pick day 15. Let's do that. I don't want to have a confusion there. So let's do a date of intervention is day 15. So on day 15 in the model, we want the intervention to go into effect. This is how many days it will last, because we want to, that's something, you know, you intervene in a certain day, and how many days are you going to intervene for? So number of intervention days. Let's start that with 4. So let's say there's aggressive social distancing for 4 days. Let's look at the effect of that in the model. And then what day will day intervention ends? Ends. So this will simply be the day that it starts plus the amount of days that it exists is day 19. So on day 15, your intervention will start, and on day 19, your intervention will stop. All right, I will stop this video there, and then we'll add some more stuff.